Network lessons. Troubleshooting your network. Troubleshooting your network. Troubleshooting is the process of identifying, locating and correcting problems that occur. Experienced individuals often rely on instinct to troubleshoot. However, there are structured techniques that can be used to determine the most probable cause and solution. When troubleshooting, proper documentation must be maintained. This documentation should include as much information as possible about the problem encountered, steps taken to determine the cause of the problem, steps to correct the problem and ensure that it will not reoccur. Document all steps taken in troubleshooting, even the ones that did not solve the issue. This documentation becomes a valuable reference should the same or similar problem occur again. When a problem is reported, verify it and determine the extent. Once the problem is confirmed, the first step in troubleshooting is to gather information. Gathering information. One of the first ways to gather information is to question the individual who reported the problem as well as any other affected users. Questions can include end-user experiences, observed symptoms, error messages and information about recent configuration changes to devices or applications. Next, collect information about any equipment that may be affected. This can be gathered from documentation. A copy of all log files and a listing of any recent changes made to equipment configurations is also necessary. Other information on the equipment includes the manufacturer, make and model of devices affected, as well as ownership and warranty information. The version of any firmware or software on the device is also important because there may be compatibility problems with particular hardware platforms. Information about the network can also be gathered using network monitoring tools. Network monitoring tools are complex applications often used on large networks to continually gather information about the state of the network and network devices. These tools may not be available for smaller networks. Once all necessary information is gathered, start the troubleshooting process. Approaches to troubleshooting. There are several different structured troubleshooting techniques available, including top-down, bottom-up, divide and conquer. All of these structured approaches assume a layered concept of networking. An example of a layered approach is the OSI model, in which every function of communication is broken down into 7 distinct layers. Using this model, a troubleshooter can verify all functionality at each layer until the problem is located and isolated. Top-down starts with the application layer and works down. It looks at the problem from the point of view of the user and the application. Is it just one application that is not functioning, or do all applications fail? For example, can the user access various web pages on the Internet, but not email? Do other workstations have similar issues? Bottom-up starts with the physical layer and works up. The physical layer is concerned with hardware and wire connections. Have cables been pulled out of their sockets? If the equipment has indicator lights, are they on or off? Divide and conquer typically begins troubleshooting at one of the middle layers and works up or down from there. For example, the troubleshooter may begin at the network layer, by verifying IP configuration information. The structure of these approaches makes them ideally suited for the novice troubleshooter. More experienced individuals often bypass structured approaches and rely on instinct and experience. They may use less structured techniques such as trial and error or substitution. Software utilities for troubleshooting connectivity. A number of software utility programs are available that can help identify network problems. Most of these utilities are provided by the operating system as command line interface (CLI) commands. The syntax for the commands may vary between operating systems. Some of the available utilities include ipconfig, displays IP configuration information. Ping, tests connections to other IP hosts. Tracert, displays route taken to destination. Netstat, displays network connections. Nsookup, directly queries the name server for information on a destination domain. Troubleshooting using ipconfig. Ipconfig is used to display the current IP configuration information for a host. Issuing this command from the command prompt will display the basic configuration information including IP address, subnet mask and default gateway. Ipconfig all. The command ipconfig all displays additional information including the MAC address, IP addresses of the default gateway and the DNS servers. It also indicates if DHCP is enabled, the DHCP server address and lease information. How can this utility assist in the troubleshooting process? Without an appropriate IP configuration, a host cannot participate in communications on a network. If the host does not know the location of the DNS servers, it cannot translate names into IP addresses. Ipconfig, release and ipconfig, renew. If IP addressing information is assigned dynamically, the command ipconfig, release will release the current DHCP bindings. Ipconfig, renew will request fresh configuration information from the DHCP server. A host may contain faulty or outdated IP configuration information, and a simple renewal of this information is all that is required to regain connectivity. If after releasing the IP configuration, the host is unable to obtain fresh information from the DHCP server, it could be that there is no network connectivity. Verify that the NIC has an illuminated link light, indicating that it has a physical connection to the network. If this does not solve the problem, it may be an issue with the DHCP server or network connections to the DCHP server. Troubleshooting using ping. If the IP configuration appears to be correctly configured on the local host, next, test network connectivity by using ping. Ping is used to test if a destination host is reachable. The ping command can be followed by either an IP address or the name of a destination host, as for example, ping 192.168.7.5, ping www.cisco.com. When a ping is sent to an IP address, a packet known as an echo request is sent across the network to the IP address specified. If the destination host receives the echo request, it responds with a packet known as an echo reply. If the source receives the echo reply, connectivity is verified. If a ping is sent to a name, such as www.cisco.com, a packet is first sent to a DNS server to resolve the name to an IP address. Once the IP address is obtained, the echo request is forwarded to the IP address and the process proceeds. If a ping to the IP address succeeds, but a ping to the name does not, there is most likely a problem with DNS. Tracert. The ping utility can verify end-to-end connectivity. However, if a problem exists and the device cannot ping the destination, the ping utility does not indicate where the connection was actually dropped. To accomplish this, another utility known as Tracert must be used. The Tracert utility provides connectivity information about the path a packet takes to reach the destination and about every router, hop, along the way. It also indicates how long a packet takes to get from source to each hop and back, round trip time. Tracert can help identify where a packet may have been lost or delayed due to bottlenecks or slowdowns in the network. The basic Tracert utility will only allow up to 30 hops between a source and destination device before it assumes that the destination is unreachable. This number is adjustable by using the H parameter. Other modifiers, displayed as options in the graphic, are also available. Netstat. Sometimes it is necessary to know which active TCP connections are open and running on a networked host. Netstat is an important network utility that can be used to verify those connections. Netstat lists the protocol in use, the local address and port number, the foreign address and port number, and the state of the connection. Unexplained TCP connections can pose a major security threat. This is because they can indicate that something or someone is connected to the local host. Additionally, unnecessary TCP connections can consume valuable system resources, thus slowing down the host's performance. Netstat should be used to examine the open connections on a host when performance appears to be compromised. Many useful options are available for the Netstat command. Troubleshooting using Nsookup. When accessing applications or services across the network, individuals usually rely on the DNS name instead of the IP address. When a request is sent to that name, the host must first contact the DNS server to resolve the name to the corresponding IP. The host then uses IP to package the information for delivery. The Nsookup utility allows an end-user to look up information about a particular DNS name in the DNS server. When the Nsookup command is issued, the information returned includes the IP address of the DNS server being used as well as the IP address associated with the specified DNS name. Nsookup is often used as a troubleshooting tool for determining if the DNS server is performing name resolution as expected. Connectivity issues. Connectivity problems occur on wireless networks, wired networks and networks that use both. When troubleshooting a network with both wired and wireless connections, it is often best to troubleshoot using a divide-and-conquer technique to isolate the problem to either the wired or wireless network. The easiest way to determine if the problem is with the wired or the wireless network is to 1. Ping from a wireless client to the default gateway. This verifies if the wireless client is connecting as expected. 2. Ping from a wired client to the default gateway. This verifies if the wired client is connecting as expected. 3. Ping from the wireless client to a wired client. This verifies if the integrated router is functioning as expected. Once the problem is isolated, it can be corrected. LED indicators. Regardless of whether the fault is present on the wireless or wired network, one of the first steps of troubleshooting should be to examine the LEDs, which indicate the current state or activity of a piece of equipment or connection. LEDs may change color or flash to convey information. The exact configuration and meaning of LEDs varies between manufacturers and devices. 3 types of LEDs are commonly found on devices: power, status and activity. On some devices, a single LED may convey multiple pieces of information depending on the current status of the device. It is important to check the equipment documentation for the exact meaning of all indicators, but some commonality does exist. Inactive LEDs may be an indication of a device failure, port failure, or cabling issues. It is possible that the device is non-functional due to faulty hardware. The port itself might also have become faulty due to hardware or improperly configured software. Regardless of whether the network is wired or wireless, verify that the device and ports are up and functional before spending large amounts of time trying to troubleshoot other issues. Connectivity problems. Wired host cannot connect to the integrated router. If the wired client is unable to connect to the integrated router, one of the first things to check is the physical connectivity and cabling. Cabling is the central nervous system of wired networks and one of the most common issues when experiencing inactivity. There are several issues to watch for in cabling. 1. Be sure to use the correct type of cable. Two types of TP cables are commonly encountered in networking: straight-through cables and crossover cables. Using the wrong type of cable may prevent connectivity. 2. Improper cable termination is one of the main problems encountered in networks. To avoid this, cables should be terminated according to standards. Terminate cables via 568A or 568B termination standard. Avoid untwisting too much cable during termination. Crimp connectors on the cable jacket to provide strain relief. 3. Maximum cable run lengths exist based on characteristics of the different cables. Exceeding these run lengths can have a serious negative impact on network performance. 4. If connectivity is a problem, verify that the correct ports are being used between the networking devices. 5. Protect cables and connectors from physical damage. Support cables to prevent strain on connectors and run cable through areas that will not be in the way. Troubleshooting radio problems. Wireless host cannot connect to the AP. If the wireless client is unable to connect to the AP, it may be because of wireless connectivity problems. Wireless communications rely on radio frequency signals, RF, to carry data. Many factors can affect our ability to connect hosts using RF. 1. Not all wireless standards are compatible. The 802.11 5 GHz band is not compatible with the 802.11 B per gram N standards, 2.4 GHz band. Within the 2.4 GHz band, each standard uses different technology. Unless specifically configured, equipment that conforms to one standard may not function with that conforming to another. 2. Each wireless conversation must occur on a separate, non-overlapping channel. Some AP devices can be configured to select the least congested or highest throughput channel. Although automatic settings work, manual setting of the AP channel provides greater control and may be necessary in some environments. 3. The strength of an RF signal decreases with distance. If the signal strength is too low, devices will be unable to reliably associate and move data. The signal may be dropped. The NIC client utility can be used to display the signal strength and connection quality. 4. RF signals are susceptible to interference from outside sources, including other devices functioning on the same frequency. A site survey should be used to detect for this. 5. APs share the available bandwidth between devices. As more devices associate with the AP, the bandwidth for each individual device will decrease, causing network performance problems. The solution is to reduce the number of wireless clients using each channel. DHCP issues. Determining if your computer is obtaining the correct IP address. If the physical connection to the wired or wireless host appears to be connecting as expected, next, check the IP configuration of the client. The IP configuration can have a major impact on the ability for a host to connect to the network. An integrated router, such as the Linksys wireless router, acts as a DHCP server for local wired and wireless clients and provides IP configuration, including the IP address, subnet mask, default gateway, and possibly even IP addresses of DNS servers. The DHCP server binds the IP address to a client's MAC address and stores that information in a client table. On the home Linksys wireless router, This table can be examined through the Status local network page in the GUI. The client table information should match the local host information, which can be obtained from the ipconfig all command. Additionally, the IP address on the client must be on the same network as the LAN interface of the Linksys device. The LAN interface of the Linksys device should be set as the default gateway. If the client configuration information does not agree with information in the client table, the address should be released, ipconfig, release, and renewed, ipconfig, renew, to form a new binding. If both the wired and wireless clients are obtaining the correct IP configuration, and can connect to the Linksys device, but are unable to ping each other, the problem is most likely occurring on the Linksys device. Check all configurations on the Linksys device to ensure no security restrictions could be causing the issue. Troubleshooting the ISR to ISP connection. Wired and wireless hosts can connect to each other, but not to the Internet. If hosts on the wired and wireless local network can connect to the integrated router and with other hosts on the local network, but not to the Internet, the problem may be in the connection between the integrated router and the ISP. There are many ways to verify connectivity between the integrated router and the ISP. Using the GUI, one way to check connectivity is to examine the router status page. It should show the IP address assigned by the ISP and should indicate if the connection is established. If this page shows no connection, the integrated router may not be connected. Check all physical connections and LED indicators. If the DSL or cable modem is a separate device, check those connections and indicators as well. If the ISP requires a login name or password, check that they are configured to match those given by the ISP. Using the GUI, password configurations can normally be located on the Setup configuration page. Next, try to re-establish connectivity by clicking the Connect, or IP address Renew, button on the status page. If the integrated router will still not connect, contact the ISP to see if the issue is occurring from their end. If the status page shows that the connection is up, but a ping to an Internet site fails, it may be that the individual site is down. Try pinging another site to see if that is successful. If not, check for security measures that are enabled that may be creating the issue, such as port filtering. Documentation. Network documentation is an important part of any troubleshooting process. Network documentation should include a normal or baseline measurement of network performance against which potential problems can be judged. The performance baseline can include the types of traffic normally expected, as well as the volume of traffic to and from servers and network devices. The baseline should be documented just after the network is installed, when it is running optimally. Baseline performance should be re-established after any major changes to the network are implemented. Additionally, documentation such as topology maps, network diagrams and addressing schemes can provide valuable information when a troubleshooter is trying to understand the physical layout of the network and the logical flow of information. When troubleshooting, documentation should be maintained during the troubleshooting process. This documentation can be a valuable reference and can be used when future issues arise. Good troubleshooting documentation should include: initial problem, steps taken to isolate the problem, results of all steps taken, both successful and unsuccessful, final determined cause of the problem, final problem resolution, preventative measures, using outside sources for help. If, during the troubleshooting process, the troubleshooter is unable to determine the problem and its resolution, it might be necessary to obtain assistance from outside sources. Some of the most common sources for help include previously kept documentation, online FAQs, frequently asked questions, colleagues and other network professionals, Internet forums. Using the help desk. The help desk is the end user's first stop for assistance. The help desk is a group of individuals with the knowledge and tools required to help diagnose and correct common problems. It provides assistance for the end user to determine if a problem exists, the nature of the problem, and the solution. Many companies and ISPs establish help desks to assist their users with networking problems. Most large IT companies run help desks for their individual products or technologies. For example, Cisco Systems offers help desk assistance for problems integrating Cisco equipment into a network, or problems that may occur after installation. There are many ways to contact a help desk, including email, live chat, and phone. While email is good for non-urgent problems, phone or live chat is better for network emergencies. This is especially important in organizations such as banks where small amounts of downtime can cost large amounts of money. If necessary, the help desk can take control of a local host through remote access software. This allows help desk technicians to run diagnostic programs and interact with the host and network without having to physically travel to a job site. This greatly reduces the wait time for problem resolution and allows the help desk to assist more users. As an end user, it is important to give the help desk as much information as possible. The help desk will require information on any service or support plans that are in place along with specific details of the affected equipment. This can include make, model and serial number along with the version of firmware or operating system running on the device. They may also require the IP and MAC address of the malfunctioning device. The help desk will require information specific to the problem including symptoms encountered, who encountered the problem, when the problem manifests, steps taken to identify the problem, results of steps taken. If this is a follow-up call, be prepared to provide the date and time of the previous call, the ticket number, and name of the technician. Be at the affected equipment, and be prepared to provide the help desk staff with access to the equipment if requested. A help desk is generally organized in a series of levels of experience and knowledge. If the first-level help desk staff is unable to solve the problem, they may escalate the problem to a higher level. Higher-level staff are generally more knowledgeable and have access to resources and tools that the first-level help desk does not. Record all information regarding the interaction with the help desk, such as time, date of call, name, ID of technician, problem reported, course of action taken, resolution, escalation, next steps, follow-up. By working together with the help desk, most problems can be resolved quickly and easily. Once resolved, be sure to update all documentation accordingly for future reference.